Last episode, we proved that accuracy lies on a malware table. A do nothing model scored 97% and caught nothing, and PRAOC told the truth. So now we trust PRAOC. Good. But a high PRAOC raises the next question every malware team asks in the same breath: what is the model actually looking at? You've got a 0.985 PRAUCPE classifier. Before you ship it to the EDR, you need to know whether it learned real malware structure, packer entropy, suspicious imports, a missing signature, or whether it latched onto some artifact of your sample set. This episode opens the hood with gain importance. Misconception killed. A static malware model is a black box. You just trust the score. It isn't. The same PE header that the loader parses, sections, imports, entropy, signature, is the entire feature vector, 12 numbers, and everyone is human readable. We draw the header strip so you see the model eats exactly what a reverse engineer reads first. Misconception killed. The model decides the features are interchangeable. No, some signals carry the whole detector. We show two PE files side by side, a clean signed binary versus a packed dropper. The dropper's entropy bar is pinned to the top. Its import count collapses, its signature flag flips to 0. 3 numbers already separate them before a single tree splits. Misconception killed. Feature importance means how often a feature is used. That's weight importance, and it's misleading. A feature used in 1,000 shallow splits can still be noise. Gain importance measures how much each split actually reduced the loss. We animate one tree split, dropping the loss by a measured amount. Gain is the sum of those drops. One high gain split beats 100 cosmetic ones. Misconception killed. All 12 PE features pull their weight. They don't. The gain bars sort themselves and one signal towers, suspicious API count at 130, more than triple the next. Then packer score and entropy, while timestamp anomaly sits near 2, basically dead. The detector is really a few signal model wearing a 12 feature coat. Knowing that is how you survive feature drift. You watch the handful that matter. Misconception killed. Hey, gain tells you a feature means malicious. This is the trap that sets up the whole back half of the course. Gain tells you a feature is useful for splitting. It says nothing about direction. Is signed earns a real chunk of gain, but the bar can't tell you whether signed pushes toward benign or whether the model learned something quirky. Importance is a magnitude with no sign. To get direction per sample, you need SHAP, and that's episode 12. Open 05 pmalware.py, 1 seed, 12 renamed PE columns, 1 bar chart, fully reproducible in Colab. We build the world with make classification at random, state 23, 15,000 binaries, 12 features, 9 informative, a 60-40 benign to malware, split with class as epimom12, so the classes are separable but not trivial. Then we rename the synthetic columns onto real PE header names, and sections entropy is signed, suspicious API count, packer score. So the strongest synthetic signals land on the genuine malware tells. Stratified 75-25 split with the same seed, so the 1/506 malware samples in test are reproducible to the row. Stratify matters. A random split could starve the test set of the rarer class and wobble every metric downstream. The model XGB classifier up to 500 rounds with early stopping. It settles at round 193. Max depth of 4, ATI 0.05, subsample 0.9, eval metrics IUCPR. Shallow trees plus many rounds. Gradient boosting's bread and butter on a wide mixed table. We report the security honest set, PRAOC 0.985, then sweep the threshold to pin FPR at 1.2% and read recall 0.896. Precision at that operating point is 0.98, when 349 caught 27 false alarms. The hero line, CLF, get booster, get score, importance type once gain. The gain argument is doing all the work. The default weight would count splits and mislead you. We sort, take the top 12, and that's the chart. We plot it as a horizontal bar chart, descending, longest bar, threat, red, FF5C5C. Suspicious API count towers at 130, packer score and entropy follow, and the bottom 5 barely register. The figure, the printed top gain, line, and the on-screen headline are the same 3 names in the same order. So gain ranked the malware tells, suspicious imports, packer entropy, missing signature, and told you which features carry the detector. What it refused to tell you is which direction each one pushes a single suspicious binary. Next episode S06, we leave PE files for NetFlow, an intrusion detector overflow records, where the lesson is tuning the core tree knobs, max depth ETR subsample, and reading a learning curve so the model fits the attack and not the flow noise.